And this video will serve as your limits review. Getting started, let's look at question 1. In question 1, you're asked just which of the following must be true. And here, the word must, you have to make sure beyond a shadow of a doubt this has to be true. So as we're looking through here, all of these answers are going to seem correct, but only one of them would really be correct. And that one would be choice 3. So that's going to tell us that that's going to have to be answer choice B. Now, the range of f contains 4, not if there's a hole in our graph. And do remember that our limit can exist if there's a hole in the graph, and that hole means that the point's not really there. So, do we have to say that the range of f contains 4? No. And the same is true for option 2. We don't know that the value of 5 is at 4. It could be anywhere else. So that one we know doesn't have to be true. So option 3, as x approaches 5 from the left, f of x approaches 4. That's the one that has to be true. So we have answer choice B. Okay, from these others, you have to pay attention to which direction your limit is coming in from, so that is important. So if you look at the very first option here, notice that x approaches 2 is coming in from the left side. Here's our 2 coming in from the left side. We can trace along our function, but notice that here as we get closer and closer to x being 2 from the left, our y value is getting closer and closer to 3. So that tells me my answer choice for number 2 has to be B. By the same idea, let's trace along our graph. On the next side, we're coming in toward 2, but we're coming in from the right side. And notice as we get closer and closer and closer to 2, the intended height for y is going to be 0. So that's going to be answer choice A. Now, number 4, there's no direction. So here you have to find the limit from the left and from the right, and they have to be heading toward a common y value. And notice from our answers from 2 and 3, they're not, so here my answer should be E. The same is true for 5. You're not given a direction, so you have to come in towards here's x equals 5, and so we have to trace him from the left and trace him from the right. And when we do that, notice our intended height looks like it's going to be 4. So here I get answer choice A for number 5. Now let's look at number 6. Now number 6, f at 5, wants a for sure value for 5. It wants the ordered pair. That's going to have to be this option up here. And so notice the exact y value there is 8. So that's answer choice B. Number 7. Here you're wanting to know, well, where would all of the x values be to where f is not continuous, fails to be continuous. So if you're not continuous, that's going to happen whenever you have a vertical asymptote or where you have holes in the graph. That's going to be the two places where you're not going to be continuous. And if we look over here at our graph, notice we see we are not continuous here. So we know at -5 we're not continuous. Also here we're not continuous. And so that's going to be at -1. And then up here we're not continuous. So that's going to be at +3. So that looks like that's going to be answer choice D. Now, some people have questions about, well, there's filled in values here. There's for sure points. Now, that does make for a continuous domain, but it does not imply that we are continuous at that particular point. So do be careful with that idea. Let's write in the right answer choice here was was D, not B, sorry. So D. All right, so for number 8, we are talking about end behavior here. And with end behavior, we talked about a function being top heavy, we talked about it being bottom heavy, or we talked about it being balanced. And so if it was balanced, then we looked at our ratio of coefficients. Now number 8 is trying to trick you because it's not written in standard form here, exponent descending form. So you have to go look for your highest power on top and bottom. And notice if we compare 3x to the 5th, and we're comparing that to negative 7x to the 5th, these are balanced exponents. They're balanced. So my end behavior or horizontal asymptote, same thing, is going to be negative 3/7. So that's answer choice B. By the same reasoning, if we look at number 9. Now number 9, here we have, let's see, the highest power on top. So I'm talking about negative 5x to the 7th. And I'm comparing that to the bottom, negative 3x to the 6th. So this is top heavy, which we would say our horizontal asymptote is not defined. In other words, my graph's not going toward here as x approaches positive or negative infinity. My graph's not running horizontally with that. It's probably running vertically. So that means we've got to figure out, well, is my answer choice D or E? So we have to come back and by reasoning, let's think about, well, what's going to happen? We're plugging in a negative big number. Well, we know negative 5 over negative 3 is going to be a positive 5/3. But what if I plug in a negative big number? So I still have my 5 and my 3. I have a negative big, and I'm going to raise it to the 7th power. And in the denominator, I have a negative big, but I'm going to raise that to the 6th power. So if we notice that negative raised to the 7th, that's going to be a negative value. The denominator is going to be a positive value. So that means we're going to end up with a negative. So that's telling me that this graph is tending toward negative infinity. So my answer should be E. Very similar reasoning. We could look at our answer choice here, or 10, looking at that problem. Well, notice x is approaching negative 5. Negative 5, well, if I plug in negative 5, I get negative 2 over 0. I would need to factor and cancel, but there's nothing to factor and cancel. So that is indicating to me that I have a vertical asymptote. And we're saying, okay, well, it might not exist here. Well, that does tell me, again, I need to look to see, well, is this tending toward positive or negative infinity? So let's go ahead and sketch a graph that will help with this. So let's see, this is going to be our rational function, and we just finished up graphing rational functions. We have a vertical asymptote at negative 5. And let's see, since our numerator is negative, that's telling me my graph is going to do something like this, and the other portion should be up here. So as x approaches 5 from the right, notice that my graph is tending toward negative infinity. So that means my answer choice is going to be E. With our next set of questions, we're looking to see what our answer would be, and we have to pay attention to which direction our limit is coming from. So for part A, we're looking at the limit as x approaches 2. Well, we don't have any kind of direction given to us, so we have to trace in from the left and also from the right. So notice both directions would be approaching negative infinity. For part B, if you look at the graph, and we're looking at this x value approaching 5, and we're not given a direction, so That means we have to approach from both left and right. So if I do that with this graph, notice from the right side and from the left side, we're tending toward positive infinity. Oh, I wrote that under the wrong one, folks. We're tending toward positive infinity. Well, for part C, we're approaching -3 from the left. So it looks like we're tending toward negative infinity there. Now from the right, it looks like from the right we're tending toward positive infinity. So for question E, this is asking us, well, what is the limit as x approaches -3? Well, we noticed from C and D we did not get the same direction, so our answer does not exist. For this set of problems, we are trying to determine each part of our answers here, 1, 2, and 3. So we're still talking about our end behavior. We're talking about heading toward negative infinity and then positive infinity. So let's see what answer choice for I would be, or the first one. We're looking at our limit as x approaches negative infinity. So again, that's our end behavior. So we need to look to see, are we top heavy, bottom heavy, or balanced? And notice here the highest power on top, -5x. The highest on bottom is 7x squared. So this is going to be bottom heavy. So that one's a bottom. So that means that my horizontal asymptote is y equals 0. So therefore my limit as x approaches negative infinity is going to be 0. And the same is true for the second one. We are approaching positive infinity, but it's really not going to change the whole bottom heavy situation. So that answer should be 0. And then for the third, then that's the equation for the horizontal asymptote, which is going to be just y equals 0. All right, so let's look at part B. Same idea here. Well, if we take the highest on top and compare it to the highest on bottom, well, this is top heavy, and that we said that the horizontal asymptote did not exist. We still have an end behavior though, so we need to see, well, what's this graph doing? If we don't have a horizontal asymptote, then my graph's not tending toward the left or the right. My graph is actually tending up or down toward positive or negative infinity. We just have to check our sign to see which one. So for answer choice 1 here, let's see, we're tending toward negative infinity. So I'm going to compare these leading coefficients, 3x to the 6th, or 3 times negative infinity, or negative big. Let's do that. So a negative big number raised to the 6th over -9 times negative big to the 4th. And so checking our signs here, notice that's going to be a positive value on top over, and then in the denominator we're going to get a negative value. So that's going to give me a negative. So here my answer would be, on the first one, we are tending toward negative infinity. So let's try the second part. Now this time we're tending toward positive infinity. So we're going to say 3 times a positive big value raised to the 6th over -9 times a big value raised to the 4th. And notice again, we're going to get a positive in the numerator. We're going to have a negative in the denominator. So that's going to tend toward negative infinity. And we've already said that for the third answer choice here does not exist. We do not have a horizontal in behavior, or a horizontal asymptote, sorry. All right, so let's look at part C. Now part C, we can label that top heavy if you want to. Keep in mind that with the graph of this, if you strip away everything, our dominating factor here is x squared. So I know somewhere through here I have a parabola, and it is turned upward because x squared, the coefficient of that, is positive. So as we tend toward negative infinity, notice that my y values are tending toward positive infinity. Our next, well, what about toward positive infinity? Our y values are still tending toward positive infinity, but for our horizontal asymptote does not exist. In other words, my graph is not running horizontally as x increases with that bound. All right, so part D, very similar. I would use the fact of what I know this graph looks like. It's x cubed and a negative. So if we sketch that, then I know, let's see, instead of our graph going it's normal, it's negative. So it's going to look something like this. So if we're tending toward, x is tending toward negative infinity, our y values are tending toward positive infinity. For the second part, as x heads toward positive infinity, our y values are heading toward negative infinity. And again, for this one, we did not have a horizontal asymptote, so it does not exist. Okay, looking at this next one, f of x here. So as x approaches negative infinity, looking at this, here's our highest dominating power in the numerator and denominator. So if we look at negative 53x squared over x squared, this is balanced. So, well, that's good news, because if it's balanced, then we know the answer. If that's 1 there, then let's undo that. We can think of that as 1x squared. So my end behavior and horizontal asymptote sitting right there. So for 1, as x approaches negative infinity, my limit's negative 53. Here, that looks terrible. For the second one, still the same, positive 53. And then for the third one, we do have a horizontal asymptote this time, and it is y equals negative 53. All right, and for f, I would do the same as far as graphing it. We know what a square root function looks like, so let's go ahead and sketch that. And we know this is flipped upside down, and it has been shifted to the left 7. So we're going to have something that looks like this. So here's going to be our graph. And so again, for the first one, for part I, you are heading toward negative infinity. So looking at this is a strange one, because as x tends toward this direction, well, it does not exist. There's no graph over there. Well, for the second one, as x tends toward positive infinity, then our y values are also tending toward positive infinity. And then for the third here, we don't really have a horizontal asymptote here, so we can say that one does not exist. Right, for these piecewise functions, we're trying to figure out whether or not our function is continuous at that particular value that they're giving us. And so really the best way to do that is to do a quick sketch of the piecewise function. Now we're concerned about at x equals 1. And so let's do a quick t-chart for the top part. And notice in our t-chart that here for x being negative 1, I'm going to talk about that first part. So if I plug in negative 1, it looks like we're going to get 2 minus a negative 3. So we're going to get 5. And then if we plug in a negative 2, let's see, we're going to get 8 plus 6, 14. So if we sketch this, we can go ahead and do a good sketch of it. Notice that negative 1, and then we're up here at 5. So we have that for sure point, and this is a parabola, so it's probably tending on up toward that direction. Now if we look at the other part of our graph, this portion here, so I'm just going to draw a dividing line. And let's talk about, again, we're still going to start at negative 1, but it's going to have to be an open circle there. And if we plug in, we're going to get negative 1, 6. So negative 1, 6, and it's an open circle. Now we know this is a line with a negative slope, so it's going to tend toward negative infinity there. Now the question itself is asking, well, is this particular function continuous at x equals negative 1? And very quickly we can see that this point at negative 1, that y value, is not the same as this y value. So are we continuous at negative 1? The answer is no. And we've proven it with our graph and our t-chart. So using that same idea, here we're going to try it with g of x. And again, we're going to do a good little quick sketch here. We know what our square root function looks like, and we want to know about values of x that are less than 1. So I'm going to start at 1, and if I substitute in, that gives me the square root of 4, which is 2. So I know at 1, 2, I have an open circle. And let's see, we are doing values less than. So if I use 0, then I'm going to have the square root of 5. So square root of 5, well, that's got to be just a little bit bigger than 2. So we're going to call it 2.1. So we're at 0, 2.1, so a little bit bigger. Let's see, we could do 0 and negative 1, or negative 2, negative 3. What about, let's do negative 4, because that's going to give us a nice neat. That's going to give me the square root of 9, which is 3. So here at negative 4, we're all the way up at positive 3. So I think we see that our graph is tending to look something like this. Now let's look at the other side. So I'm going to swap colors. And now let's talk about this part of it. So now we're going to look at values where x is greater than 1. And if we plug in 1, we're going to get a 4. And really automatically we're going to see, well, we know that's a parabola. We go over 1, we're going to go up 4. So that part is going to be here. And again, we know that's going to be some kind of parabola going on up. We don't know if that's really the vertex, but we do know it's going to continue upward. So let's compare these values. Those, even though you have the same x values, your y values are different, so you can't be continuous here at x equals 1. So the answer to part B is no. All right, for the last part of this review sheet, we are looking at, again, limits graphically. For number 15, the limit as x approaches 1 from the left, hopefully you got that to be a positive 1. Now from the right should be a negative 1. So if you look at your graph again, that's where our values are coming from. Notice if you're coming in toward 1 from the left, again, you're tracing in, get my lightsaber back up here. So you're tracing in, getting closer and closer to x being 1, and the intended height from the left is 1. But from the right, as we come in, that intended height is negative 1. So that's where we're getting those answers from. And so notice that part 7, or number 17, is saying, well, what is the limit as x approaches 1? You have to consider left and right. They're not meeting at an exact value, so it does not exist. Well, what is on 18 the difference? This is the for sure value, and if you notice, the for sure value is down here at that closed circle, and so that should give you negative 1. By the same tracing idea, as you go through your graph, and now you're approaching 4, and 4 is a vertical asymptote for this graph. So as we approach 4 from the left, we are tending toward positive infinity, and from the right, tending toward positive infinity. Since both the left and the right side are tending toward the same exact direction, then that is positive infinity. Now for number 22, it's asking about a sure value again, but for x equals 4 is a vertical asymptote. So a for sure value of 4 does not exist. Now, if we notice on 23, we're talking about the end behavior or the horizontal asymptote as x tends toward positive infinity, increasing without bound. That is going to give you 0. So again, very quickly going through the graphs of limits of graphs. Okay, number 24 we will discuss in class. This is when you may have several different answers. One particular answer, let's see, if we do an XY axis, and x is approaching 10 from the left and from the right is -2, so I'm going to put -2 down here. And so 10 from the left and right, so I'm going to put 10 here. And so my graph is hitting there, but look at the for sure value for -10. For sure value for -10 is going to be +2. So I've got to have a for sure point there. But then that tells me down here, I'm going to have an open circle. So that's going to be interesting. We are tending toward that value. So it looks like, let's see, what else could we pick out for this part? X approaches 0 from the left is -infinity. Oh, and then from the right is positive infinity. Well, if that graph's going in two different directions, that's telling me, uh-oh, we can't see that. Let's see if I can get a darker color. Yeah, there we go. That's telling me that I've got a vertical asymptote here. Because again, I'm tending toward -infinity, so I know my graph, whatever it is doing, I know it's tending this direction. And then as we approach from the positive, it's going to have to be tending up this direction. All right, so let's look at 5. Well, let's see. Our limit here, x approaches 5 from the left is 0, and f at 5 is 0. So that tells me over here at 5, I have a for sure point because f at 5 is 0. So I know that for sure point exists. And I know the limit as x approaches 5. So it sounds like this is probably doing something like that. Of course, that's terrible. Let's see if we can't fix that. Let's see. So I think I have enough information now to safe to say, okay, I know this is happening over here. Okay, so as x approaches 5, from the right side, we have 4. So we need to look way up here at 4. So, okay, so I'm going to have an open circle there because it's not for sure. All right, and then let's see, f at 7 is 4. So f at 7, here at 7 is also 4, and that's a for sure point. Goodness. And I know as x approaches -infinity, we're tending towards 0. So let's see, our graph, there's several different ways you could connect these. And so this one I think is going to tend this way. And over here we've got to connect these two dots. Now we can't come backwards because then it wouldn't be a function. So we could connect it, it could go that direction. It could go several different directions there. But again, you could have several different answers here. So don't get hooked up on just this one because you might have a different one. This would be a good bonus question to look for on your test.